Now we're doing absolute values with inequalities. Okay. So it's not an equation. It's not an equal sign. It's an inequality. Less than, greater than, less than or equal, greater than or equal. This one is less than or equal. So there is some similarity, okay, to when it was an equation. First off, you still get the absolute value expression by itself. Well, the absolute value is all by itself. I mean, there's no, +2 or anything on the same side. So yeah, the absolute value expression is already isolated. Once that has taken place, then you're going to, like before, break it up twice. Now, when you change the sign over here, just like we did with the equations, what that's going to do is it's going to flip the inequality around, because in effect, what's happened is we have multiplied the 7 by -1. And when you multiply or divide by a negative, you flip the inequality around. Okay. Now, again, at this point, we would typically solve for y, but that's already done. So it says graph the solution to the inequality on the number line. So let's do that. All right. So let's see. So this guy looks like this. This one here says all numbers less than or equal to 7. All right. So because of the or equal, I shade in the circle. And then this one over here says all numbers greater than or equal to -7. So there's my -7 and blah, blah, blah. Okay, so that's what those two mean, but we're supposed to end up with a single graph for the solution. So how do we combine the two? Because there's more than one way you can do it. And so this is where we remember the gola. I know, like, that's not a word. So once you get the absolute value expression by itself, which it started out that way, you ask yourself, do I have a less than or a greater than symbol? Well, we got a less than. Okay, so less than means we're going to do an and. Okay, we're going to do and. If it was a greater than symbol, we would do or. And we learned before that and, we're going to connect them with an and. We learned before that and means intersection. It means take what they have in common. Well, what they have in common is everything from -7 to 7. So if I pick one of them up and dump it on the other, they will overlap everywhere from -7 to 7. And that would be the answer right there. Now, in interval notation, just for practice, it looks like that. I get brackets, not parentheses, because the circles are shaded in on the 7 and -7. And that would be how you would do it. You can do this also on the calculator on the graph to help you out, but this kind of problem is not that tough. I'll do that here in a moment when we get a tougher one. So on this one, they're saying, all right, this time we're going to give you the graph. You come up with the absolute value expression. And they're not going to get, especially hard at all, because it can get pretty tricky real easily. Well, we know the solution starts at -6 and heads out, and at +6 and heads out. So it's a good bet we're going to need the number 6 in there. All right. And it's a good bet we're going to need absolute value of the variable. And if you take the absolute value of numbers like -7, -8, -9, 10, 7, 8, 9, 10, numbers that are shaded in, though the absolute value of those numbers are greater than 6, aren't they? Yeah, they're greater than. And because the endpoints are open circles, I'm not going to put the or equal sign there. I'm just going to leave it greater than. Okay. If they were shaded in, then I would put the or equal sign in there, and that would have been correct. Okay. Let's try one more of those. Okay, so once again, we're going to have absolute value of some number, And I think we can agree that 5 is the number we want to compare to. And if I take the absolute value of any of these numbers that are shaded in, you'll notice that they are all smaller than 5, aren't they? They're all less than 5. But, it can be equal to 5, okay, because the -5 and the 5 are shaded in as well. And that would be how you would do it. All right, so now we're back to having the inequality and then writing out the solution on the number line. So as always, we get the absolute value expression by itself, which is already done for us. And then once that's done, we break it up into, I'm going to just, we break that up into 2 inequalities. So the first one is just what you had, just without the absolute value bars. And the second one, we change the sign of the right side, which causes the inequality symbol to flip. And so we add 4 on the, we add 4, and we add 4. Whoops, that's not an equal sign. It's a greater than. Okay, now what is connecting them? Is it greater? I'm sorry, is it and or? Well, Gola says we had a less than sign. Less than means and. So we're looking for where they are overlapping, looking for the intersection. Okay, so v less than 9 looks like this. And v greater than -1 looks like that. So where do they overlap? Well, everywhere from there to there. Okay. Or in other words, our solution looks like this. And of course, you can write it in interval notation, like, whoops, like that. But this is what Alex is looking for, because it says write your answer on a number line. All right, last one. So we get the absolute value expression by itself by adding 22 to both sides. So the absolute value of 2u is greater than or equal to 7. Cool. All right. And let's see. So now that we've got that, now we can split it up. And we can say, all right, so 2u is greater than or equal to 7. 2u is less than or equal to -7. So if I divide everything by 2, I get this. Okay, now the question is, what do we connect them with? And or? Okay, and since this is Idaho, to help me remember the GOLA, I can say, go back to LA, Californian. Or I can say, go Lakers, or just whatever works for you. Well, once the absolute value expression was isolated, we had a greater than sign. So greater than means we're going to connect with an or. So we're going to do or. In other words, union. So let's see what that looks like. Well, the first one says we want all numbers that are greater than or equal to 3.5. And the second one says we want all numbers that are less than or equal to -3.5. And or says union. It says keep everything as shaded. All right, keep it all. So our solution set would look like this. Now, for some crazy reason, this were an and problem, then there'd be no solution, because this stuff here and this stuff here, they don't overlap. And means intersection. It means where do they overlap. Now, if I was going to write this in interval notation, I'll just type it, then it'll be easier for you to read. In interval notation, actually, you know what? I'm not going to do that because I need to do the infinity sign. It would be negative infinity to negative 3.5. And infinities always have the parenthesis because you cannot include them. But the negative 3.5, I include that. And then the other half would be 3.5 to infinity. And then to connect the two pieces of my solution set and merge them into a single solution set, I put a union symbol in between. And now everything is wonderful. Now, what about doing this on the calculator? Well, let's see how to do it. Let's start off by plugging in the left side for y1 and the right side for y2. All right, so I've got that. And because it's an inequality, not an equation, I'm going to put the entire statement on y3. So math right 1, 2x, right arrow, minus 22. And then I need the greater than or equal sign. So second math, option 4, negative 15. Okay, so then I'm going to go to Zoom 6. Hopefully that'll show me something wonderful. Okay, I think I need to zoom out a little bit more. I'm just going to go zoom. I'll just go zoom out. Hopefully that'll be okay. Uh-oh. That is, I'm going to go back to Zoom 6. That makes it hard to see the Y3 line. Tell you what, I'm going to go back to, I'm not really using the top part of my screen. So on window, I'll just go to Y max, pull that down to maybe like 3, and then the Y min, pull that down to maybe like negative 15, and hopefully that'll be enough. Okay, pretty good. Oh, and I can even see the red line. Okay, so that Y3 line, that shows me where the solution is. It says, hey, the solution is right here, and it's right here, but it's not in the middle. So, so right there, I know that the solution is from this endpoint and all the way to negative infinity, and from this endpoint all the way to negative infinity. But what are the endpoints? Well, as always, they will correspond. Let's see if I can do this cool line here. They will correspond with the intersection point, okay, right there, and with that intersection point right there. So we have to, find those intersection points. So I'll do second trace 5, enter, 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 and nothing happened. That was weird. Let me try it again. Second trace 5. Oh, I didn't hit the 5. Enter, enter, enter. Okay. So one of the intersection points is going to be 3.5, and that's the one over here on the right. So from 3.5 to infinity and beyond. Okay, but what about this intersection point right here with the blue with the red? We don't need that anymore. So I'll go second trace 5, and now I'm going to move closer to that intersection point. Okay, that's certainly close enough. And then 3 enters, and negative 3.5. So is where they intersect. So at negative 3.5 to negative infinity, that's going to be my solution, and that's how you can check it with the graph.